Hello, in this video I'll explain the concept of opening and closing. So first we'll see with opening. Opening is nothing but first erosion and then dilation. Short form OED, opening, erosion, dilation. So what happens is if there is an image X, this is my X, and there is a structuring element B. So first I will erode X by B, then the result will be dilated again by B. So this is my opening. Let's see what happens. Erosion. So in erosion what we want is we see where there is a perfect match of ones. Where there is a perfect match of ones. We can see here the seed point. Here the seed point is this element. As it is, whenever there is odd, you see the center thing is the seed point. So this is an odd number of columns, so there is a center, so hence this is the seed point. In the previous lectures we have seen where the seed point was something like even, so at that point of time the first element becomes the seed point. Okay, so this is my X, this is my B. So what I'll do is I'll put the seed point on every pixel. Seed point should be traced on every pixel. So when I trace the seed point on every pixel, I see that this seed point will come over here. That is, the whole thing will come first over here. So here there is nothing, here there is 1, here there is 0. So I see that these two ones are not matched. This one is matched, here the 1 and here there is 1, but beside it should be 1 which is not there, and beside this should be 1 which is not there. So hence the output is 0. So we can see that there is no perfect match of ones wherever you trace the image, Hence the output is all zeros. So when you erode X by such a structuring element B, you see the erosion output is all zeros. Now when you'll dilate this thing, eroded output again with B, you'll get the same output because there is no 1, so there is no 1 to replace the structuring element, and hence the output will be zeros. Now let us see closing. In closing what we do is first we'll do dilation, then we'll do erosion. So this is easy to remember, CDE. This is alphabetically A, B, C, D, E. So this is easy to remember, CDE. So first dilation, then erosion. Consider the same image 1 1 1 and the structuring element B. So here this is the seed point. So first I'll put this seed point over here, so it will occupy this space. So I see when I put this seed point over here, for dilation the rule is wherever there is one matching with the seed point, you replace the entire thing by the structuring element. So here I have replaced the entire thing by the structuring element. Similarly over here I see there is 1, so again this thing will be replaced entirely by the structuring element. So here I can see the whole thing is replaced by the structuring element. Similarly over here, here. So basically there I had a thin line of ones, here there is a thick line of ones. I can see that there are 3 thick lines of ones. Also I can see that a row is added, a column is added on both the sides. So this was 1 2 3 4 5 columns, here there are 7 because of this element and this element. Now this thing is to be eroded by the same structuring element 1 1 1. So when this thing is eroded, I see here I have a perfect match of ones. That is, when I place the structuring element over here, when this seed point matches with this, I get here also there is 1 and here also there is 1. Here also there is 1 and here also there is 1. Basically this thing is applied over here, I'm seeing wherever there are ones in the structuring element, there is 1 in the image, and hence that is replaced by 1. This thing is not applicable over here. See, if my seed point is matched over here, the seed point comes over here, so this will be the overlap, and I see that there is a 1 over here which is not reflected over here, so hence that is a 0. Similarly others there will be 0. Also I can see the same thing is over here. When there is a seed point is over here, there is 2 ones on the sides that I want, and hence output is 1. So this is the output. Okay, the same thing if you do with MATLAB, the thing that is over here, that change is over here. For MATLAB, when you put the seed point over here, what happens is, here actually there is nothing. So when you put the seed point over here, this one is actually going out of the matrix. So what MATLAB does is, it considers this as don't care. So it does not care whether whatever is over here, it just neglects it. So here this one is actually just neglected. So when the seed point is over here, so this one is just neglected, and what I am left with is the one that is in the besides. So MATLAB will give you an output where here also there is 1. This also is 1 according to MATLAB, because it just does not care if the structuring element goes out of the matrix. So because of this, MATLAB will give you 1 over here. The same thing is repeated over here. When I put the the seed point over here, so my structuring element goes like this, and this element goes out of the matrix, and that is don't care. So what I just want is a 1 besides over here, so that I have. Hence for MATLAB this will also be 1. While talking of MATLAB, when I do dilation, I also see that when you take this as x and this as b, and at MATLAB you use the command im dilate, and you do the following dilation, you'll see this as the output. So MATLAB does not actually add the 2 columns that we have added over here. It just gives you the same size as the image size. So this will be the output that you get. Again, when this is eroded by the same structuring element, you see that over here MATLAB will give a 1. MATLAB is giving a 1 over here with the same concept as when you put the seed point over here. This thing becomes don't care. This goes, because this is the seed point, so this seed point is applied over here, and this becomes don't care, and the only thing that we need is a 1 beside it. There it is over here. Hence this is 1. The same thing is applied over here too. When you see over here, when the seed point is applied over here, you see that this again becomes don't care. It goes out of the window, and there is a 1 beside it. Here there is a 1 beside it. Hence the output is 1 for MATLAB. The same thing is valid for here and here also. So if you use MATLAB, this will be the output that will be shown to you. And this is also right. You can just mention a reason that if the structuring element goes out of the matrix, those are considered as don't care. Thank you.